Come to me. All of you are getting my voice on screen. Those are attending in online. Is my voice on screen is clear to all of you guys? Please confirm to me. All of you are getting my voice on screen. Those are attending in online. Guys, please confirm to me. All of you are getting my voice on screen. Those who are attending in online. Guys, please confirm to me. All of you are getting my voice on screen. Those are attending in online. Right. Good afternoon, guys. And check it what we completed in the last session. What content can be discussed there in the last class. I think so. We are discussing about the differences between Java and others. This topic we are discussing in this particular content, the differences between Java and others. Already we understand two differences clearly. What are the two differences can we understand there? First one is C and C++ are static programming languages, whereas Java is a dynamic programming language. Clear? That's the very first difference what we understood. C and C++ are static programming languages and Java is what their dynamic programming language. Can you tell me guys why C and C++ are static programming languages? Java is a dynamic programming language. How can you say this point here? Now there are given some reason for it clearly. What was the reason I've given there? If any programming language allows static memory allocation, that is the memory allocation is provided for the primitive data types at a compilation time, then that programming language is what? Static programming language. What are the examples for static programming language? C and C++. In C and C++ applications, memory will be allocated for the primitive data types at a compilation time only, not at the execution time. Okay. Next one. How Java is like a dynamic programming language. And first of all, what is a dynamic programming language? If you observe this point, if any programming language allows dynamic memory allocation, that is the memory allocation for a primitive data types at a runtime, not at compilation time, then that programming language is what their dynamic programming language. Example is Java. Java is the best example for what their dynamic programming language. Right. In Java applications, memory will be allocated for the primitive data types at a runtime only, not at a compilation time. At what time here? No, at a runtime only, not at a compilation time. Okay, fine. Some diagrammatic representation again. What is compilation time? What is runtime? What is the purpose of the compilation? All the points can be understood. Tell me here, what is this compilation actually? What is the purpose of the compilation? Two reasons now. What are the two reasons here? First one is to translate program from high level representation to low level representation. And second one is what there? To check the developer's mistakes in programs, we need to perform what there? Compilation. Next, second point. Preprocessor is required in C and C++, but a preprocessor is not required in Java. What is preprocessor actually? There we understood clearly what is a preprocessor, what is the location of the preprocessor, why it is required in a C and C++ and why it is not required in Java. This points we have to understand. See this here, no? Preprocessor is the first phase in the compilation process. In the diagram, if you observe this clearly, C program I have taken, compilation we have performed there, .exe file, execution, output. In the compilation, overall, 4 phases are existed. What are the 4 phases in compilation? Preprocessor, compiler, assembler, loader, link editor. Compiler, if you observe this, lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and code generation. Here my required point is preprocessor is the first phase in a compilation process. But what it is able to do, what exactly its work, what it is able to do, this points here we have to understand now. Let's see this point here, all of you here, all of you observe carefully. In C and C++, the complete predefined library is provided in the form of header files. The complete predefined library is provided in the form of header files. Example is what there, yesterday.h, conio.h, math.h, something else. If you want to use predefined library in C and C++ applications, first we have to include header files into C and C++ applications. To include header files in C and C++ applications, we have to use hash include statements. Examples are hash include yesterday.h, hash include conio.h, hash include math.h. Like this I have taken. When we compile C and C++ applications, preprocessor will perform the following actions. What are the various actions that preprocessor is able to do? Preprocessor will recognize all the hash include statements. Preprocessor will read all the provided header files names. Preprocessor will check whether these header files are existed in C and C++ softwares or not. If the required header files existed in the C++ softwares, then a preprocessor will load the required header files to the memory. This type of loading predefined library to the memory is called as static loading. This type of loading is called as what there? Static loading. Observe carefully. After that, after completion of this particular one here, another point here what I am telling to you. In C and C++, preprocessor is required. In C and C++, preprocessor is required to recognize all the hash include statements in order to include header files content to the memory. In order to load header files content to the memory. For this particular reason, we required what there? Like hash include statements. That means preprocessor is required. Diagram I have given there. In Java, why preprocessor is not required? That I am giving clarity. In Java, the complete predefined library was provided in the form of classes and interfaces in packages. Java.io, Java.util, Java.sql. Clear. Next one is in Java applications. If you want to use the predefined library, then we have to include packages in the Java applications. In Java applications, if you want to use the predefined library, then we have to include packages in the Java applications. To include packages in Java applications, we have to use what statement here? No, import statement here we are able to use. All right, sir. Import java.io.star, import java.util.star, import java.sql.star, like this. When we compile a Java program containing package statements, then we have to perform, then the compiler will perform the following actions. What are the various actions which are performed by the compiler? Compiler will recognize all the import statements. Compiler will take all the provided package names. Compiler will check whether all the provided packages exist or not in the Java software. If the provided package names do not exist in the Java software, then the compiler will raise an error like package XXX does not exist. If the provided packages exist in the Java software, then the compiler will not raise any error. At the same time, the compiler will not load any predefined, any package content to the memory. If compiler is not loading any content to the memory, any package content to the memory, but who will load this predefined library in Java applications? No. All right, for that I am giving clarity. In Java applications, compiler is responsible for checking whether the packages exist or not in the Java software. If not, compiler will raise an error. If yes, compiler will not raise any error. Compiler is not responsible to load any predefined library to the memory. When we execute Java applications, JVM will load the required libraries to the memory as per the application requirement. Here, loading the predefined library at runtime is called as what there? Dynamic loading. In Java, preprocessor is not required. Why? Because in Java, hash include statements are not existed. Why? Because in Java, header files are not existed. Java has classes and interfaces and packages. To include them, Java has import statements to recognize and execute import statements. Java has provided compiler and JVM. So because of that reason, preprocessor is not at all required in the case of Java software. And then Java related diagram also we have given. Then after that, yesterday I given the total interview question there, one important interview question. What are the differences between hash include statements and import statements? Hash include statements are available in C and C++. Import statements are available in Java. Hash include statements are able to include the libraries which are available in the header files. Import statements are able to include the libraries which are available in classes and interfaces in packages. Hash include statements supporting static loading, import statements supporting dynamic loading. Hash include statements are evaluated by the preprocessor, import statements are evaluated by the compiler and JVM. To include more than one header file in C and C++ applications, we have to use more than one hash include statements. All right, now these are the things here we are having clearly. Right, sir. So these are like what the examples that I'm telling here. To include hash include statements are evaluated with the preprocessor, import statements are evaluated by the compiler and the JVM. Right, sir. 1 minute. Yeah. To include more than one header file in C and C++ applications, we have to use more than one hash include statement. Some examples are given. To include more than one class or more than one interface of the same package, there we have to use single import statement with which notation there? No, star notation. These are the points here we understood. Okay, example I've given, import java.iva.star. All right, sir. Up to this part we completed second definition. Now we are, I think we started with what the third difference here. What is the third difference here? We completed the C and C++ are platform dependent programming languages, but Java is a platform independent programming language. If any programming language allows its applications to perform compilation and execution on the same operating system, then the programming language is called platform dependent programming languages. Examples for platform dependent programming languages are what they are? C and C++. If we compile C and C++ programs on a Windows operating system, then the compiler will generate a .exe file which contains directly executable code, and it is having the same operating system, same Windows operating system representations. In the above context, to execute Windows represented .exe file, we need the same Windows operating system at runtime. We are unable to use other operating systems at runtime. Why? Because other operating systems are unable to process Windows representations. All right, sir. Due to the above operating system dependency at runtime, C and C++ are platform dependent programming languages. Right, sir. Then as per that, I give you some diagrammatic representation. After that, we understood clearly the content here, how and why C and C++ are platform dependent programming languages. Now we have to understand what exactly the meaning of platform independent programming language. Here we have to understand what exactly the meaning of what the platform independent programming language. After that, we are going to understand Java is a platform independent or dependent. There we are going to decide clearly. But first of all, we have to understand how Java is platform independent programming language. What is a platform independent programming language first? Clear? All right, sir. Now try to understand this point now. All of you observe carefully. Listen, all of you listen carefully. First of all, understand the definition for the platform independent programming language. If any programming language, programming language allows its applications. If any programming language allows its applications to perform compilation on one operating system and execution is on another operating system. Come again. In the case of platform dependent programming languages, what was the definition I've given? If we compile and execute, that means if any programming language allows its applications to compile and execute on the same operating system. But now what's the definition I'm telling there? If any programming language allows its applications to perform compilation is on one operating system and execution is on another operating system. Compilation is on one operating system and execution is on another operating system. Then the programming language is platform independent programming language. Platform independent programming language. That's it. Observe carefully. If any programming language allows its applications to perform compilation on one operating system and execution is on another operating system, then the programming language is what? The platform independent programming language. Best example I'm telling there, Java. Of course, if you want to take Python is also. Anyway, my intention is not to discuss about Python. My intention is to discuss about like what there, Java. So got it or not? Fine. Next one is after completion of this. Here the question is why Java is a platform independent programming language. How can you decide Java is a platform independent programming language? Here this question here we have to answer. That's it. Now I will give some clarity. Now try to understand it. How Java is platform independent programming language. This is our required information. Please try to understand the point here. Right. First of all, I want to prepare a simple diagram. Try to understand this diagram now. Right, sir. Observe carefully. For example, here I want to take a Java file. This is what? A Java file means that .java. This is what there? .java. Right. Whenever we are getting this .java file, then we want to compile .java file. This is like what I am telling there, compilation. What we are performing there, no? Compilation. When we compile this Java file, automatically here we are able to get what file here? Dot class files here we are able to get. Dot class files. Whenever we are getting these dot class files, now observe carefully. Compilation is on one operating system and execution is on what their other operating systems. That's the actual concept. So this is compilation process. Now I want to execute the same program on multiple operating systems, not on a single operating system. On multiple operating systems, I want to execute my program. That's why here I'm taking like what there execution. Here I'm going to perform here. when we execute this program, automatically some outputs here we are able to get. Output here we are getting. Now this is like what their execution. This execution we are going to perform on a separate operating system. Later I'll confirm which operating systems here we are using now. Now here I want to take execution process. This is another execution. This is another execution. And this is another execution. Overall, how many times execution is going on there now? Tell me 4 times. Now let me decide my operating systems now. I want to compile my program on Windows operating system. Next term, I want to execute the same program on Linux operating system. I want to execute the same program on Unix operating system. I want to execute the same program on Mac operating system. Next one is the same Windows operating system I want to use again. For compilation, we have used Windows, and for execution also, I want to use what are Windows. This is the overall structure I have taken. Please try to recognize it. How many Java programs here we have taken? Now tell me, how many Java programs here we have taken? Only one Java program. Am I right or not? Only one Java program here I have taken. How many times we are compiling my Java program? How many times we compiled our Java program? Only one time. Only one time we compiled our Java program. Got it or not? Okay, only one time we compiled our Java program. Here we are getting some dot class files. What files here we are getting there? No, dot class file. Okay. Now observe carefully. When we compile Java program on Windows operating system, here we are going to get what file here? No, dot class file. What is this dot class file? Previously, in the case of C and C++, when we compile programs, we got .exe files. What is the nature of the .exe file? What is the nature of the .exe file? There are given some nature. .exe file contains directly executable code, and it is depending on the operating system which we use for compilation. That is, the generated .exe file contains Windows represented executable code. .exe file is a platform dependent or not? Come on, .exe file is what there? Platform dependent. Now here I am telling there about this class file. Observe carefully. Class file contains class file contains bytecode. Class file contains what code here? No, bytecode. Observe carefully. Class file contains what code here? Bytecode. What is this bytecode now? It is not directly executable code. Class file contains what code here? No, bytecode. It is not directly executable code. It is an intermediate code. It is an intermediate code. Not directly executable code, but it is an intermediate code. And it is not having any operating system representations. It is not having any operating system. Representations including Windows operating system representations. Including Windows operating system representations. Observe carefully what exactly the point here I'm giving there. This is important point. This is the required point. Now try to understand it now. Dot class file contains what code here? Bytecode. It is not directly executable code. It is an intermediate code and it is not having any operating system representations, including Windows operating system representations. Why I'm stressing on this point here now? We compiled our program on Windows. Even though we compiled our program on Windows, dot class file doesn't have Windows representations. Dot class file has some intermediate representations. It is not directly executable code. But .exe file contains executable code or not in C and C++. But in the case of Java, dot class file is not directly executable code. It doesn't have directly executable code here. Clear? All of you are getting clarity on these points now? That's okay, fine. But here my point is what? Okay, up to now compilation we completed. Dot class file nature we understood, just keep aside. Come to this execution process. If you want to execute any code, any bytecode, anything on Linux operating system, that code must have Linux representations. If you want to execute any code on Unix operating system, that bytecode must have Unix representations. Similarly, if you want to execute any code on Mac operating system, that code must have Mac representations. Similarly, if you want to execute anything on Windows representations, no, that code must have Windows representations. So execution required local operating system representations. But here what we provided there, now tell me, dot class file we provided. Dot class file contains bytecode. Bytecode is not directly executable code and it is not having any operating system representations including Windows. It's a neutral bytecode. It's an intermediate code. If we send this dot class file to the execution process on Linux, this execution process is not going on with the dot class file. This dot class file is not going to be executed. Why, sir? Why it is not going to be executed? Then now tell me. Yeah, this is neutral code, but here it required what operating system representations? No, Linux representations. This is neutral bytecode. If you want to execute this on Unix operating system, it required which operating system representations? No, Unix representations. If you want to run this bytecode on Mac, no, Mac representations here we required. If you want to execute this on Windows, no, here what representations here we required? No, Windows representations here we required. So, all of you are okay or not? So slowly people are going to the sleeping. Almost continuously. Then I'm observing all the people there. Slowly. Now it's a starting point. If we take the same point next to 2 to 3 minutes of time, no, they'll be sleeping. No? Right, sir. So their eyes are totally red. With the half eyes only they are looking at my face now. Some people are already, they closed their eyes. Gradually their heads are moving like what the left side. Right, sir? Okay. All of you are okay? All of you are able to understand? Fine. Just I will give 10 minutes of time to you. If you want to sleep, you can sleep now. Then after that, I will start my class. Yes, sir. Shall we go for this? Can I go for 10 minutes of time? I think this thing is better, right? What topic we are discussing? Think of it. I'm having very much habituated for sleeping. I have a bad habit. If in front of me, if anybody else is sleeping now, automatically I'm getting sleeping. If I'm sleeping and if I'm teaching the Java in the sense, in place of Java, I may teach C++. In place of C++, I may teach Python. Huh? Going on. Your life is going to be totally different, right? All right, sir. It's not like that. Then what I'm telling to you, put more concentration. Listen. The topic is very, very important. I said to you yesterday, yesterday's topic is up to C++. Now today's topic is what there? Java. This is our required topic. When the topic is not required, there you are understanding clearly. Yesterday your concentration is too much. Perfectly understood. But when the required topic is coming, you are not putting concentration there. Yes, sir. Right. Let's move on to the point here. All of you put more concentration. Now I'm asking some questions to you. You only answer for my questions. You only answer for my questions now. Right. Now tell me. Java file I have taken. Where I'm compiling the Java file? Windows operating system. So which files here we are getting there? Dot class file we are getting. Tell me what is the nature of the dot class file? Come on, I given some information also. Dot class file contains byte code. Dot class file contains byte code. It is not directly executable code. Then what next one? It is an intermediate code and it is not having any operating system representations, including Windows operating system representations. Just compare this statement with the .exe file content. No, what difference you identified between .exe file and .class file? .exe file contains a directly executable code or not, and it has the local operating system, that means Windows operating system representations, as we compiled our C program on Windows operating system. So which file is a platform dependent, which file is a platform independent? .exe and .class we are talking. Which one is platform dependent? Which one is a platform independent? .exe file is what there? Platform dependent. .class file is what there? Platform independent file here. That's the difference here we understood. Okay, then after that I given one more point. Exactly up to this point also people understood there previously. But when I'm talking about the next point, what is that next point there? If you want to run any code under Linux operating system, that code must have Linux representations. Exactly when I'm talking this point, people have started sleeping. That's why I'm repeating that entire part here. Now again, now understand it now. Don't sleep now. The point is what there? If you want to run any code on Linux operating system, that code must have what representation? No, Linux representation. If you want to run any code on Unix operating system, then that code must have Unix representations. If you want to run any code on Mac operating system, that code must have Mac representations. If you want to have any code on Windows operating system, that code must have what there? Windows representations. Sir, all of you are getting clarity or not up to this point here? That's okay, nice. After that, after completion of this, here data class file contains a byte code. It is an intermediate code. It is not directly executable code. It is a neutral code. But if you want to execute this neutral code on Linux now, this neutral code must have Linux representations. If you want to execute this on Unix now, it must have Unix representations. If you want to execute this on Mac now, it must have Mac representations. If you want to execute this on Windows now, it must have what there? Windows representations. All of you get my point or not? All right, sir. Now here the point what I'm telling to you. Observe carefully. Understand this clearly. No. So it is not possible to execute this bytecode onto the Linux, Unix, Mac, and Windows. If it is not possible, almost all the situation is same as in C and C++ or not. What we have seen in the case of C and C++, the same situation is coming to the Java or not. Exactly in this particular moment, in this particular situation, Java people have done some manipulation with the bytecode to execute that bytecode in all the operating systems. There Java people have given some mimic, some innovation they have done. What that innovation they have done there? Simply they provided one solution. What the solution they provided here? No, that solution would be what they observe carefully. Dot class file contains a neutral code. If we provide any translator or any converter to convert the bytecode from neutral nature to local operating system representations. Understand my point? If they provide any translator or a converter to convert program from dot class file, that means bytecode to local operating system representations. If any conversion is provided, then programs are executed or not. That bytecode will be executed in all the operating systems or not. This is what Sun Microsystems has done directly. All right. So what I'm telling there here, Sun Microsystems has provided some converters here. This is not done in C and C++, but it was happened in Java. That's why Java is a specific norm. Now this is happened in the case of Java. Then what Java people have done there, between bytecode and this execution, they have provided some conversion mechanism, some conversion process they have provided. Some conversion process they have provided. Here also be they have used one converter, and here also be they have used another converter. So the converters they have provided clearly. So now just I want to provide like what there conversion, or in other words I can say like what there translation. Right, sir? Conversion or translation. Conversion. Then what next one can know? Conversion. Then what next one can apart from this? Conversion. Right. Next one is what there? Conversion. Like this. Now tell me conversion mechanisms here we are provided clearly. Right. Then what is going to be happen there? Now tell me. This is neutral bytecode. When we provide this neutral bytecode to this converter, then what this converter is doing there? This converter is converting bytecode from local representation to neutral representation to the local operating system representations. Understand? All of you know. Now here also be what this conversion is doing there. No, this conversion mechanism is converting neutral bytecode to Linux operating system representations. Now here also be this converter is taking neutral bytecode as an input, converting that neutral bytecode into Unix representations. Understand my point here? This converter is taking neutral bytecode as an input and converting into Mac representations. This converter is converting neutral bytecode into Windows representations. Now, when this converter is converting bytecode from neutral representations to Unix representations, now this bytecode we can run under Linux representations or not. Then finally here we are able to get output or not. Directly here we are able to get what there output here. All of you observe carefully. So in this way our Java program is going to be executed. Right, a bit more concentration here what I'm telling you now. So here the point is what there, when we giving this dot class file to this converter will convert this neutral bytecode into the Unix representation. If I give this Unix represented bytecode to the execution process, there we are able to get what there some output. Now this execution is going to be happen on Unix representations, then it is going to be executed, we are able to get some output. Come again what I'm telling there, neutral bytecode we are given to this converter. Now this converter will take this neutral bytecode as an input and converting this neutral bytecode into Mac representations. That Mac represented bytecode is given to this execution will be performed on Mac represented bytecode, then we are able to get some output. Right, whenever we are giving this neutral bytecode to the converter, this converter is converting this neutral representation into Windows representation. Windows represented bytecode is giving to what there this execution process. This execution process will execute Windows represented bytecode, and here we are able to get some output. Yes sir, all of you get my point or not? So in this overall process here what I am telling there, with the help of the converters, that neutral bytecode is converted to the local operating system representations. Then execution is going to be performed on local operating system, there we are able to get some outputs directly. Is clear? All of you are getting clarity on these points now? Now the programs are going to be executed or not? Finally, the Java has done this type of magic when the bytecode is generated and before executing our code. These converters are playing very good role. Then because of this particular reason only, then Java programs are executed under multiple operating systems. But here the question is, how Sun Microsystems are provided these conversions? How Sun Microsystems has provided these conversions? That is the question now. Sun Microsystems as a provided, please all of you recognize this. Sun Microsystems as a provided this conversion along with the execution. Sun Microsystems has provided this conversion along with the execution. Here also Sun Microsystems has provided this conversion along with what their execution. All right, in all the cases, conversion and execution both are provided by Sun Microsystems in a single device. Sun Microsystems has provided this conversion and execution both in a single device, in a single component. The name of that single component is what there? JVM. The name of that single device is what there? JVM. Right, here we are having what there? JVM. The name of this component is called as what there? JVM. JVM is what there? Java Virtual Machine. JVM is what there? Java Virtual Machine. This is what exactly the reason why JVM is coming into the picture. This is a requirement of the Java. Now I'm asking one question to all of you guys. Now try to answer for it. In Java, what exactly the purpose of the JVM? What is the purpose of the JVM? Two responsibilities. What are the two responsibilities? No, translate Java program from bytecode to local operating system executable code. Local operating system executable code is called native code. Native code is called as what there? Native code. Translating Java program from bytecode to native code. Translating Java, that means translating Java program from bytecode to native code. That is the responsibilities of what there? Responsibility of this conversion. Then whenever native code is available, the native code is executed by whom? JVM. That means execution. Execution process will execute what there? That native code. Here execution is nothing but an interpreter. Execution is nothing but what there? An interpreter. Interpreter will execute our code. Fine, whatever it may be. JVM responsibilities are only two. What are the two responsibilities for JVM? First one is what there? Translation. And second one is what there? Execution. Translation plus execution is nothing but what there? JVM. Yes, sir. All of you are getting clarity or not? Now, I'm asking one question to all of you. I'm asking one question to all of you guys. Now try to answer for my questions now. All of you observe carefully. How many times we compiled our program? Come on. How many times we compiled our program? Only one time or four times? Compilation I'm talking there. How many times we compiled our program? Only one time. But how many times we executed our program? How many times we execute our program? Four times. Four times we execute our program. But only one time we compiled our program. But how many times we execute our program? Four times we executed our program. Is that point is clear or not? Now tell me, I'm asking this question to you. In all the four times execution of our program, how many JVMs we have used there? Is that only one JVM or four JVMs? Come on, now think and give the answer here. My question is what there? One time we compiled our program, that's nice. Four times we execute our program, okay. But how many JVMs here we have used there? Is that only one JVM or four JVMs? One JVM or four JVMs? Think and give answer now. One JVM or four JVMs? Right, sir. Answer is 4 JVMs. Not one JVM. Answer is what there? 4 JVMs. Answer is not one JVM, 4 JVMs. Please recognize this. An answer is not one JVM. How many JVMs? No, 4 JVMs. Then immediately we got a question. How 4 JVMs is the answer? Right. Simple question, simple answer. I'm telling to you. Simple conclusion. Forever, we have to remember this conclusion. That conclusion would be what there. All of you observe carefully. The conclusion is what there. Java programming language is a platform independent programming language because of JVM only. If no JVM, no chances to say Java is a platform independent programming language. If no JVM, Java is no more platform independent. If JVM is available, then only Java is what there, platform independent. So Java is a platform independent programming language because of JVMs only. But JVM is a platform dependent. JVM is what there, platform dependent. JVM is not platform independent. JVM is what there, platform dependent. That is this point here. Most of the people may get confusion in this particular area. Most of the people are thinking Java is a platform independent programming language. So JVM is also be platform independent. People are thinking in this way. No, that's not the right point here. Then the right point is what there. Java is a platform independent programming language because of JVMs only. But JVM is what their platform dependent. How, sir? How can you say Java is a platform dependent? I'm telling to you, not only JVM, the complete Java software, is a platform dependent. Not only JVM, the complete Java software is what their platform dependent. Java programming language is platform independent. Java software is a platform dependent. Whatever the program I have written, Java program, that is independent of the operating systems. In any operating system, my program will run. But the Java software which I downloaded from internet, which I'm going to install in my computer, the Java software is a platform dependent. Still, people are having question mark faces now. Still, people are not digesting this punch. Java programming language is platform independent. That I heard, sir. That's okay. Java, in the sense, platform independent. I heard. But now we are saying Java software is a platform dependent. Okay. Now I will give one point. Try to understand it. No. Java software, in the sense, we have to download from internet or not? That we have to install in our computer or not? Simple point. Now try to understand it clearly. All of you observe carefully. I want to download Java software. Now let me Google it. Now just I want to say Java download. Just I want to say like what there, Java download. All of you observe me. Java downloads, I want to click there. All right, sir. Not this one. Now I want to go for it. Right click on it. Any version, what version here we want to download, we can go for it. Java 19 and Java 17 available now. Latest version is what version here? No, 19 version here. It's existed here. It's okay, fine. I want to download this 19 version, sir. Better. I want to go for somewhat older versions than that we are able to understand clearly. Say for example, best example, Java 8 downloads. Java 8 version I want to download. All right, so now here I want to download it now. Now see this one. This is the link for Linux operating system. This is the downloadable link for Linux some other. This is the downloadable link for what their Mac. This is the downloadable link for what their Solaris. This is the downloadable link for what their Windows. Now you only tell me, as per your thought, if Java is a platform, Java software is a platform independent, no? Why some people have given, why Oracle people have given different softwares for each and every operating system? Why they have not specified a single link for every operating system? Why they specified different links for each and every operating system? Now tell me, each and every, that means these Java softwares are depending on the operating system or not? This is a proof here. This is the best proof here that Oracle people have given this Java links Java softwares with respect to the operating systems. Say for example, if I click on the last link, last two links now, we are able to get what operating system related Java software? Windows related. If I click on the next above, two more links now, there we are able to get what there? Solaris operating system represented Java softwares. First two links, first two or four links, if I click there, we are able to get what operating system related Java software is no Linux related Java software we are getting. So it shows clearly Java software is a platform dependent, whereas Java programming language, is what their platform independent. Java programming language is platform independent, whereas the Java software is what their platform dependent. Java software in the sense, Java compiler, JVM, Java profiler, jar, Java signer, jar commands, all these collections, all these tools combination is a Java software. Java software is not any other one. The tools combination is a Java software. What tools combination there? Java compiler, JVM, Java profiler, Java documentator, and so on and so on and so on. So many tools are available. All these tools combination is a Java software. All these tools are working on the basis of the operating system. All these tools are dependent on the operating system. Altogether, Java software is what their platform dependent. But Java programming language is what their platform independent. First understand it. There is a lot of difference between programming language and a software. So forget about programming language. Whatever the program I have prepared by using Java, my program, 100 lines of code I prepared, a program that is platform independent. We can compile that program on Windows operating system. We can execute the same program in any of the operating system. That is an independent. But to compile a program, we require Java software in our computer or not? To execute Java program, we require a separate Java software in our computer or not? So that software, what we have installed in our system, that is what their platform dependent. Now in the simple diagram I'm asking to you, now try to understand it. In this situation, now tell me, in this diagram, all of you observe carefully. How many times we compiled our program? Only one time. But how many times we execute our program? Four times now. Just assume it. Compilation is available on Windows operating system. This is one computer. This is one computer. Separately we execute our program or not? How many computers are available here? 4 computers now. That means overall 5 computers. Overall 5 computers. All 5 computers are independent computers only. All 5 computers are what they're independent computers only. Please recognize this point here. If it is an independent computer, no, observe carefully. How many times Java software we installed here? How many times we have to install Java software? All 5 times we require the Java software or not? 5 times we have to install the Java software or not? Here we have to install Windows specific Java software. And here in Linux, we need to install Linux specific Java software. On Unix specific Java software. On Mac specific Java software. On Windows, again, what there? Java specific software. Yes, sir. I'll get my point or not? So in that way here, we are able to confirm Java is platform independent programming language, but Java software is what there? Platform dependent programming language. That's platform dependent tool. That's it. Now this is what exactly the content here I'm giving there. Now try to recognize this clearly. Right, sir. Now I'm giving this diagram also now. Now try to understand this point clearly. I want to give some statement. I think you understood clearly my concept here. Whatever the conversation, whatever the points I'm giving here, now try to recognize this point here. They are very, very important. No, conclusions are very important. Now try to observe this clearly. When we compile Java program on Windows operating system, compiler will generate dot class file. Compiler will generate what file here? Dot class file. Observe carefully, where the generated dot class file, where the generated dot class file contains bytecode, contains what there bytecode. It is not directly, it is not directly executable code. Then what next one here? It is an intermediate code, and it is not having, and it is not have, and it is not having, and it is not having any operating system represented code. It is not having any operating system representations. Representations. It is not having any operating system representations. Good. Now observe carefully. In the above context, if we want to execute bytecode in any operating system, in the above context, if we want to execute bytecode on any of the operating system, then the bytecode must have the same local operating system representations. Observe carefully. The point is very clear. In the above context, if you want to execute bytecode in any operating system, then the bytecode must have the local operating system representations. All right. In this context, to make Java as a platform independent programming language, or to execute Java programs in all the operating systems, Sun Microsystems has provided some translation Sun Microsystems has provided some translation mechanism to translate neutral bytecode to the local operating system represented bytecode. That is what is that code? No, native code. That's what their native code. Right, sir. Now clear cut information I'm giving there. Now try to observe carefully. In the above context, if you want to execute bytecode in any operating system, then the bytecode must have the local operating system representations. In this context, to make Java as a platform independent programming language, or to execute Java programs in all the operating systems, Sun Microsystems has provided some translation mechanism to translate neutral bytecode to the local operating system represented bytecode, that is native code. Right or not? That Java has provided some translation mechanism. But how Java has provided this translation mechanism here, try to understand it now. Right, sir. In the above context, Sun Microsystems has provided the required translation. Sun Microsystems has provided the required translation along with the execution in a single component. That is, the single component is what there? JVM. That single component is what there? JVM. Observe carefully, JVM. What is that JVM actually? What is the abbreviation for JVM? No, Java Virtual Machine. Right, sir. We have a separate topic like what the JVM architecture. There I will discuss more. What is available inside the JVM? Then everything I'm going to discuss there more in the future, not immediately. But try to understand this clearly. All right, sir. Along with the execution in a single component, that is what the JVM, Java Virtual Machine. All right, now come for the conclusion, guys. What is the conclusion here? I'm telling there, Java is a platform independent programming language because of JVM. Java is a platform independent programming language because of JVMs. But JVM is a platform dependent tool. JVM is a platform dependent tool. Right, one small point here I'm telling there. Not only JVM, the complete Java software is platform dependent. The complete Java software is what there? Platform dependent software. Complete Java software is what there? Platform dependent software. That's it, guys. Now, this is the point here we have to understand clearly. Now, here I given some diagram as per that representation there. There we can understand clearly what exactly the meaning of like what there. This is JVM and how it is available here. But I want to add one more point here. Here before this. All right, sir. In Java, the main job of the JVM is number one, to translate bytecode to the native code. Native code is what the local operating system represented code. Second one is what there to execute native code. The translated code, executing translated code. That is what their native code. They are the responsibilities of the JVM. Next one is a Java is a platform independent programming language because of JVMs only. But JVM is what their platform dependent. But JVM is platform dependent at all. Note, not only JVM, the complete Java software is a platform dependent software. Right, so this is what exactly the points I'm telling there. Then the respective diagram also we have given. Right, sir. As per your awareness, as you are understanding my total topic, no. Now I'm asking one question to you. One important interview question here I'm asking there. Now try to answer for it clearly. What exactly the question here I'm asking to you? Now try to observe carefully. First one is, what are the differences between .exe file and .class file? You know already answers, almost all the answers you know. Nearly 3 to 4 answers here I want to include here for this. Now you have to understand this clearly. What exactly the answers here I'm telling there. The very first one is what there. .exe file is available in C and C++. Whereas, 1 minute. All right, sir. .exe file is available in C and C++, whereas .class file is available in Java. That's point number one. Point number two, observe carefully what .exe file contains actually. .exe file contains directly executable code. That is directly native code. In other words, what I am telling there. But .class file contains what code? You know, bytecode. Bytecode. It is not directly executable code. It's not directly executable code, and it is an intermediate code. It is what there? An intermediate code. Right, so it is not directly executable code. Now point number 3, observe carefully. You know already. .exe file is a platform dependent file. .exe file is what there? A platform dependent file. Whereas .class file is a platform independent file. It is neutral to all the platforms here. Independent file. Right or not? But another point just is a general point only, not specific to any technical, but understand it now. What's the point here? I'm telling to you, observe carefully. Point is, listen, all of you listen carefully. In general, number of viruses related softwares are provided in the form of .exe files. No virus related software is available in the form of .class file. Understand my point here? Maybe chances are available to introduce viruses related softwares in the form of what their .exe files. but no chances are available to introduce virus related softwares in the form of what there dot class file. This is one side reason I'm telling there. .exe file is a lesser secured file. Dot class file is what there more secured file. Means that .exe file is not having much security, but dot class file is having much security. This is one side reason. Another point here, what I'm telling there, C and C++ are not having very good security, but security is there, but not good, not having good security. But Java is very good secure programming language. Java has very good security. Java is very good secure programming language. All of you get my point or not? So here the point here, what I'm telling to you, .exe file is able to provide lesser security. .exe file is able to provide what there lesser security, but .class file is able to provide more security. .class file is able to provide what there more security. Right, sir. All of you observe carefully what I'm providing there. What happened? Our data is saved or not? Okay, no problem. Right, sir. .exe file is able to provide less security, whereas .class file is able to provide what there more security. Right. Now overall, this is what exactly the differences between .class and .exe. Come again here. What are the various differences are given there? What are the difference between .exe and .class files? First one is what there? .exe file is available in what? C and C++, whereas .class file is available in what? Java. .exe files contains directly executable code, whereas .class files contains what there? Bytecode. It is not directly executable code, and it is an intermediate code. .exe file is a platform dependent file, whereas .class file is a platform independent file. .exe file is able to provide less security, whereas .class file is able to provide what there more security. So these are exactly the points here we understood clearly. Sir, all of you are getting it or not? That's okay now. This is somewhat information here we can understand. So this difference is completed here now. Next difference, after completion of this, the next difference here, almost all. Third difference is completed. Now we have to understand that fourth difference. That fourth difference is what there. Pointers are available in C and C++, but pointers are not available in Java. But pointers are not available in Java. Pointers are available in C and C++, but pointers are not available in Java. All right. Now I'm asking one question directly. Tell me first of all, what is a pointer? What is a pointer variable in C and C++? As you're having some knowledge on C and C++, what is a pointer variable? Any idea? All right, it's very clear. Pointer is a variable. It able to store address locations of some other data structure. Address locations of the data. But instead of saying data, I'm telling the data structure. Address locations of the data structure. Where data structures may be a normal variable, maybe an array, or maybe a structure in C and C++, maybe in C, or maybe another pointer variable. Data structure may be a normal variable, an array, or a structure, or maybe another pointer variable. So, but in general, variables are able to store data, but a pointer variable is able to store what their address location of the data. Pointer variable is able to store what their address location of the data. All right, so now let me take this point here. Understand this clearly. Pointer variable is a variable. It is able to store. It is able to store address locations of the data structures address locations of the data structures, where the data structures may be, a variable or an array or a structure or another pointer variable. Yes, sir. All of you get my point or not? Right, sir. Now, this is the simple definition. Pointer is a variable. It is able to store address locations of the data structures, where the data structures may be a variable or an array or a structure or another pointer variable. Yes, sir. Got it or not? Okay. Right, sir. Then I want to wind up this session here. If I want to go more, I need to go for more explanation there. Why? Because we need to talk about why pointers are required in C and C++, why pointer is not required in Java. There, that points I have to talk now. So it may take a lot of explanation there. So that's why I want to take this topic on tomorrow. I want to take this topic on what day? Tomorrow. Tomorrow is a Saturday. All of you are able to come for the class? No response. If you want to come, then all I will take it. Anyway, first weekend, I don't have any problem. If you require gap, I will give it. But I'm ready to take class. I don't have any problem. People are smiling in the sense, don't want to come. Huh? Tell me, then it depends on you. If you are not coming completely, then it's a waste of time, even if I take the class now. Or else, if all of you come, then I want to take. I don't have any problem. If you don't want to come, I will call other batch to take the class here in this time now. Or if you want to take first weekend, sir, no, it's okay then. Okay, then Monday onwards, I'll continue the content here. What's your opinion? Okay, let's go for voting. How many of you wants to come to the class on tomorrow? Raise your hands. Oh, nice. How many of you don't want to come to the class? Right, result is very clear, right? So tomorrow we have a session, right? Tomorrow I want to take session, don't worry. But at what time we have to come there? One small change. Not at 4:30. Come at 4 o'clock. Tomorrow come at 4 o'clock. At least some topic maybe we can assume it. Tomorrow 4 to 5 I will take the session, 1 hour session. Anyway, this topic I started there, then I want to take this class. I want to complete this topic there and tomorrow, right? That's okay, guys, no problem. Tomorrow 4 to 5, 1 hour class I want to take. Let's have some continuity, right? Don't think about it weekend different session, right? Don't think like that. Anyway, Sunday I'm going to give gap there. Tomorrow we have a session. Tomorrow at what time we have to come here? 4 p.m. 4 p.m. to 5 p.m. Just 1 hour I'm going to take. Sharp 4 o'clock I'll come here. 1 hour I'll take, and then whatever the topic I started, then I'll finish the topic. That means that pointers topic I'll finish there. Then after that, next class will be on Monday. But tomorrow there is a class. Everybody has to come for tomorrow's class, right? Thank you, guys. Thanks a lot. I'll meet on tomorrow at 4 p.m.